Today, the data center is not only being scrutinized for uptime, but is more importantly targeted on its environmental impact. We know that carbon footprint looks at the effect of the generation of CO2 into the environment. The more CO2 we generate, the more the planet needs to absorb. Maintaining that balance is essential. At Rittal, we've always strived to ensure that the technologies we deploy are not just well designed, but are also tuned for maximum energy efficiency. Hot aisle, cold aisle systems are a common method of delivering cold air to the servers within a data center. Using computer room air conditioning, generally abbreviated to CRAC, the cold air is pushed under the floor. Using vented tiles, strategically positioned in front of the server enclosures, cold air can escape and be pulled into the server inlets. However, typically, the CRAC system needs to be overrated by 30% to ensure that there's enough air available. Also, running N+1 dual systems again reduces the system's overall efficiency. The key elements of the hot and cold aisle design is the CRAC system itself. Ensuring that this vital element is working efficiently is the answer for reducing long-term energy costs. So, understanding how a CRAC system works is important. In essence, improving the efficiency of a CRAC system can be broken down into 3 stages. Stage 1. Improving the air delivery. Most older generation CRAC systems have fans that push air vertically down. The issue with this method is that the air has to turn 90 degrees. This causes back pressure that restricts the rotation of the fan and consumes more energy. The Rittal CRAC system actually mounts the fan in the floor void, and by using a blower, the air is forced out in all directions, a bit like a water wheel. This actually improves the airflow by reducing back pressure, which in turn saves energy. Stage 2. Reducing your chiller activity. As mentioned before, the chiller produces the cold water for the CRAC system. It effectively uses a compressor and a refrigerant. The majority of your energy costs when cooling your data center is attributed to the compressor. Minimizing its activity is crucial for energy efficiency, and a simple way to achieve this is via free cooling. Free cooling is an air-to-water heat exchanger that's placed on the outside of the building. The hot water coming away from the CRAC system passes through a heat exchanger, and if the outside ambient air temperature is lower than the water temperature, the heat is lost to the outside world, a bit like a car radiator. Using the outside ambient air to reduce the water temperature obviously reduces the activity of the chiller, therefore saving power. Depending on your geographical location, up to 50% of the water can be cooled solely by free cooling, offering significant long-term energy savings. Stage 3. Creating a higher delta T. One of the key issues with hot aisle, cold aisle is that the hot and the cold air is mixed before returning to the inlet of the CRAC system, therefore reducing the delta T. This is why we've developed cold aisle containment to solve this specific issue. The cold aisle containment still uses the common components, CRAC, chiller, and hot and cold aisles, but by simply adding doors at each end of the cold aisle and fitting roof panels across the top, this stops the hot and cold air from mixing. This means that the CRAC system has a higher delta T, which makes it more efficient and therefore cheaper to run. Depending on the installation and the servers, the CRAC air outlet temperature can be raised, therefore reducing the activity of the chiller and in turn improving your mean time between failure. As a byproduct of encapsulating the cold aisle, you can also increase your power consumption per rack, typically from 5 kilowatts to approximately 10 kilowatts per enclosure. This now enables Rittal to provide a low-cost, lower-footprint, medium-density data center with a very simple mechanical add-on. Rittal's cold aisle containment system has been designed to be adaptable. The doors at the end of each aisle will fit 900, 1000 and 1200 mm deep enclosures. The roof panels also allow us to adjust the width of the aisle from 1.2 meters to 1.8 meters. The inclusion of a 100mm plenum, which increases the roof height, not only allows us to provide additional headroom, but provides important space for additional features, such as security webcams and fire extinguisher systems. Even in a site where there's no false floor, cold aisle containment shouldn't be ruled out. By introducing a liquid cooling package called LCP Inline, it effectively replaces the need for a crack system and provides up to 30 kilowatts of cooling per module. The LCP Inline still requires water as its cooling medium, and using an air-to-water heat exchanger, it blasts cold air into the cold aisle, where it's absorbed into the server inlets. To provide additional cooling capacity or even redundancy, it's simple to add additional LCP Inlines along the aisle, whenever and wherever you need them. Whether your data center is legacy or a new build, at Rittal we're able to tune the cooling to provide you with a data center that not only meets your business needs, but also provides you with a future-proofed, energy-efficient system. Going green is not a fad. Rittal has been doing it for years. We just called it good engineering. At Rittal, we work smarter to make your life easier.